the next way we can use to prove triangles similar. Are you ready to move on?
No.
Why not? The next way we can prove triangles similar is called the Sss Similarity Postulate, which is much different than the Sss Congruence Postulate. The Sss Congruence Postulate says that the sides are congruent. But the Sss Similarity Postulate, the sides don't need to be congruent. In fact, usually they're not. Instead, we say that they are proportional. Okay? So going to the side postulate, it says if three sides of one triangle are proportional. Does anybody remember what proportional means? Proportional means they have the same ratio. Which means they're the same, they reduce to the same fraction, right? Oh, goodness. Okay, if three sides of one triangle are proportional to three sides of another triangle, then the triangles are similar. So instead of congruent, it's the sides are proportional and the triangles are similar. So different than the theorem we learned last time, even though it has the same letters. The way that the theorem itself is different is side similarity instead of side congruence. Okay, we're going to do an example. Okay, this example that I'm going to do, the numbers don't appear to match the picture. But remember how the picture doesn't matter as much as the numbers. So the picture just helps us figure it out, but we don't pay attention to, wait, that doesn't look that long or that short or whatever. You just go with it, okay? So I've assigned numbers to the sides of my triangles here. And we need to figure out how they might match up if they do at all. Okay, first of all, this triangle, since all the sides are different, and all the sides are different over here, if they were to match up, wouldn't that mean that the shortest one here would match up with the shortest one over there? And the longest one here would match up with the longest one over there, right? So be very careful about that to make sure you're matching up the right pieces. Okay, in order to prove side, we have to show ratios. We can't just say, oh, it's side, like we did with congruence. We have to actually work out the fractions. Okay, so I'm going to start with side AB. AB is the shortest, so which one would it match up with if it is similar? DF? Okay. So AB would go with DF if they do work. So that would be 2, because AB is a length of 2, and DF is a length of 5. What's that ratio going to be reduced? 2/5. Okay, now let's try another set of sides. How about the medium length ones? So BC is 3, and that's the middle length in this triangle. And DE is 7.5, and that's the middle length in this triangle. How do you reduce something with a decimal in it? One way to do it is to just get rid of the decimal. To get rid of the decimal, we can actually multiply both top and bottom by 10. So that gives us 30 over 75. And then we don't have to worry about a decimal, we can just reduce it. Can anyone think of a number that divides both into 30 and into 75? 5 does, but there's a bigger one that does. What is it? 15. Yeah. So we can divide by 15 to reduce this. So 15 goes into 30 twice, and 15 goes into 75 5 times. What ratio did we just get? 2.5 ratio. Okay. Next, let's take the longest sides. So AC is the longest one in that triangle, and it's 4. And EF is the longest one in that triangle, and it is 10. What does 4 over 10 reduce to? Oh my goodness. What did we just figure out? They all have the same ratio of 2/5. We call that the similarity ratio. And now we have to write a similarity statement. Okay, so triangle ABC is similar to what? This is the hard part, is matching them up. So remember how we put AB with DF, and we put BC with DE, and we put AC with EF? So what goes with what? Let's see. Point A is between the longest side and the shortest side. Which point over here is between the longest and the shortest? See how point A is between the longest and shortest sides? Which point over here is between the longest and shortest? F. So does that mean F is going to go first in our statement to match up with A? Does that make sense? B is between the shortest and the middle. Which one over here is between the shortest and the middle? D. So D matches up with B. And then the side that's between, the angle that's between the longest and the middle is C. So between the longest and the middle is what leftover letter here? Letter E. So see how I was so careful to make sure they line up correctly based on the information in the picture? And that is by the Sss Similarity Postulate. Now, can you just answer this and leave this stuff out? No, you have to know that they are proportional to get this correct answer. Okay, last one. Give you a second to finish that up.